Hello everyone, it's Mr. Sutherland on behalf of the AP Calculus AB team again with our next topic from our free response topics review packet. This time we are going to go to the front of the packet and look at the topic 1, interpreting graphs. So if you could find your green packets or if you have printed them out, and let's take a look at first the bullet point list on topic 1. Now, as you read through this, the things that you should be able to do, I would say the two main things that you're going to do in these problems are these last bullet points. The fundamental theorem of calculus, where you evaluate an integral from the area of regions of the graph. So this is where we're going to look at finding the positive and negative area and using that to evaluate an integral. And then the second part of the fundamental theorem of calculus, where we take the derivative of an integral. For example, if this is g of x, if it is this function, and this should be an x up here, that when you take the derivative of an integral, remember that the bound goes in for the independent variable, and then you do the chain rule if needed, and then the second derivative would then just be f prime of x. Now, when you're doing these problems, the other item I would point out is that use the information that you have in the graph to answer the question. So what I mean by that is if the question asks you about information about concavity or the points of inflection, and you're looking at the graph of the first derivative, use what you know about the first derivative to answer those questions. Don't jump to the second derivative and start making conclusions, because a lot of times students miss out on explaining why they were able to use the second derivative. What about the first derivative are they able to use in order to use the second derivative? So be careful with that, and we'll see that in this first problem. So if we take a look at the first problem, again, we'll do problem 1 together, and then problems 2 and 3 will be assigned to you. You have your graph. It says the figure above shows the graph of the piecewise linear function f. For negative 4 to 12, the function g is defined by g of x is equal to the integral from 2 to x of f of t dt. So we have our integral function. Notice that our integral starts at 2. Part A. Does g have a relative minimum, a relative maximum, or neither at x equals 10? Justify your answer. So, again, what I'd like you to do is pause the video, try this part, and then when you're done, unpause it, and we'll go through it together. So, anytime a question asks whether a function has a relative minimum or relative maximum, we're always going to look at its derivative. So we know that g of x is the function from 2 to x, the integral of f of t dt. That means g prime of x, using that second fundamental theorem of calculus, is equal to f of x, which is the graph that we're looking at. So I'm going to put up here the graph of f is also really the graph of g prime. So if I want to know if g has a relative max or relative minimum at 10, then we look at 10, and our derivative is 0 there, but there is not a sign change. Therefore, the answer is going to be neither. Now, in our justification, we're going to need to mention a couple of things. First, we've got to mention why we're able to use that graph. So, since g prime equals f of x, and f of x does not change sign at x equals 10, x equals 10 is neither a relative max or minimum. Now notice in my justification, one, you include this statement. Even though we wrote it to the side, it should be included in our justification. I also, in my mind, I wanted to use the word it right here. Try to avoid that. Repeat what you're going to say rather than using those vague pronouns. All right, part B. Does the graph of g have a point of inflection at x equals 4? So remember, we're looking at a point of inflection. when we have points of inflection, most of us want to go to the second derivative and think about, oh, that's when it's 0 with a sign change. But we are given the graph of the first derivative, so let's use that to determine whether it has a point of inflection. So at x equals 4, at that point on g prime of x, it's a local maximum. The g prime is going from increasing to decreasing, which means g of x is going from concave up to concave down, which would indicate then a point of inflection. So we would say something similar to the following in your justification. Since g prime of x equals f of x, notice I have to say that again, and f of x goes from increasing to decreasing at x equals 4, the graph of g of x goes from concave up to concave down, making x equals 4 a point of inflection. Now, I might have written too much here. I believe we probably could say since g prime equals f of x and f of x goes from increasing to decreasing at x equals 4 is a point of inflection. But I wanted to be very specific about why I'm able to say that. So I probably wrote a little much there, but that's okay sometimes. But I believe what I underlined, if we look at the grading rubric, would have been accepted for full credit. Part C. Find the absolute minimum value and absolute maximum value of g on the interval -4 to 12. Justify your answer. So on the previous list of bullet points, it had the first derivative test, it had the candidates test, and this is where that is used, where we determine whether something is an absolute maximum or minimum. The first thing we look for when we determine absolute maximum or minimum, so we're going to test the endpoints, and then we're going to test the critical points. Where does the derivative equal 0 with a sign change? Here, that's going to determine that max or min value. So if we think g prime of x equals f of x, and that equals 0 with a sign change at x equals, so we're going to go back to the graph, and this part we are going to have to scroll back and forth a few times. We have a 0 with a sign change at -2 and 0 with a sign change at 6. So I am going to test those two critical points in addition to the endpoints of -4. So I'm going to start a table and space out the values here. So I have -4, -2, 6, and 12. Now remember, g of x, I'll put this over to the side, g of x is the integral function from 2 to x of f of t dt. So if I want to evaluate the function at -4, I have the integral from 2 to -4 of f of t dt. Those bounds are backwards, so I'm going to make this the opposite of the integral from -4 to 2 of f of t dt. And now I'm going to go to my graph, and I'm going to find all the areas that I could use here. So if I look from -4 to -2, that has an area of -4. -2 to 2 has an area of 8. 2 to 6 has an area of 8. 6 to 10 is -8. 10 to 12 is -4. So now we're doing the integral from -4 to 2. So that would be +4, but we have the opposite of that. So we have -4. Now the integral from 2 to negative 2 of f of t dt. We're going to have to do the same thing, the opposite of the integral of negative 2 to 2 of f of t dt. And so if I go back to our graph there, negative 2 to 2 was 8. So this is going to be negative 8. For 6, we have the integral from 2 to 6 of f of t dt. And that we can look right at the graph, and we go from 2 to 6, the area is 8. And then from 2 to 12, f of t dt. If we look back at the graph, we would find that this equals negative 4. Now, we're asked for the max and min value. Remember, that's the y value. So this has an absolute minimum value of negative 8 and an absolute max value of positive 8. All right, last part. From negative 4 to 12, find all intervals where g of x is negative. So now I'm going to make a table, and I'm going to find the values of g of x at the values of the critical points we found, in addition to the ones where the signs did not change. So the endpoints. So we got negative 4 was negative 4. We had negative 2 was negative 8. Our graph also had a 0 at 2. We did 6. The value was 8. We did 10. We did not do yet. And 12, the value is negative 4. Well, think about 2. Again, remember, our function g of x is the integral from 2 to x of f of t dt. So 2 to 2, that's going to have an area of 0. And then we need to do 2 to 10 to evaluate this missing piece here. Well, if I look back, 2 to 6 is 8, 6 to 10 is negative 8, so that's also going to be 0. So the question is, when are the values of g of x less than or equal to 0? We have no other changes in sign, so we have that it is 0 from bracket negative 4 to 2, and it is 0 or less from 10 to 12. You also could have written these in inequality notation or use the brackets. I don't believe AP would take off if you did parentheses, but it does include it, so I would go ahead and use the brackets. It gets really wishy-washy with the brackets versus parentheses argument. So now you've seen one of these problems. Go ahead and try the other two in the packet and check with your teacher as far as assessing those problems. Thank you. Bye.